Okay, so 4.3 is kind of just a short little thing. The first thing I want you to do is to copy this problem down. So pause the video, copy the problem down, and I want you to use your unit circle and what you know to evaluate this, okay? When we come back tomorrow, the first thing I'll do is ask for our answers on this, okay? All right. So for 4.3, right triangle trig, there's just some things we need to talk about. First off, if you got a triangle with a right triangle with a theta and a beta, right? Two different angles. So first off, draw the triangle. And if we let these lengths be, let's say, x, y, and z, you could see that sine of theta, so sine of theta is opposite of our hypotenuse, y over z, and cosine of beta, so cosine is adjacent over hypotenuse, they're the same thing. And the reason why is because theta and beta have a relationship. The three angles in a triangle, theta plus beta plus 90, have to add up to 180, which means theta plus beta has to add up to 90, right? So cosine of beta equals sine of theta because beta is equal to 90 minus theta. So the sine of any angle is equivalent to the cosine of 90 minus that angle because it's just the other angle in a triangle, right triangle. So these are called cofunction identities, and all the sine, cosine have that relationship. Tangent, cotangent, and secant, cosecant have that relationship. So if I were to write my cofunction identities, then I would say sine of theta equals cosine of 90 minus theta, or sine of theta equals cosine of pi over 2 minus theta. So it could be in radians or degrees. Tangent of theta equals cotangent of 90 minus theta. And secant of theta equals cosecant of 90 minus theta. Now this also works backwards. If sine equals cosine of 90 minus theta, then cosine of theta equals sine of 90 degrees minus theta. It's just either or, okay? So they can also flip-flop. All right? So it could be in degrees, it could be in radians, either way. But these are the cofunction identities. So make sure you write down cofunction identities and write these three down, and somehow indicate that it could be 90 or pi over 2. And that you can switch them. Okay. So, as far as like what is sine of 84, you could type that in your calculator if you're in degree mode and see what it is. But the point is to just say, using cofunction identities, I know that this is the same thing as cosine of 90 degrees minus 84, which is cosine of 6 degrees. So if they say using cofunction identities, write an equivalent trig expression, sine of 84 is cosine of 6. Okay? Cotangent is a cofunction with tangent. So cotangent of 4/3 pi is the same thing as tangent of, now since we're in radians, it's going to have to be pi over 2 minus the angle. And it's okay that the angle is greater than. So if I want to do a common denominator, it would have to be 6. So we multiply by 3. Multiply by 3. I wrote that. So that would have to be a 6. Multiply by 2. So I've got 3 6 minus 8 6. And that is a negative 5 6 pi. Now, to prove that, if you look at your unit circle, just threw that over. Okay, 4/3 pi is right here. And so if this coordinate point is 0, -1, and this is 1, and this is square root of 3 over 2, they're both negative. Cotangent is cosine over sine. So it'd be -1 over negative root 3 or root 3 over 3. Now this is talking about tangent of negative 5 pi over 6. So negative 5 pi over 6, well here's 5 pi over 6 right here. So negative going this way. So negative 5 pi over 6 is right here, this one. So this coordinate point is, if this is -1, 0, so 0, 1, negative square root of 3 over 2. Tangent is sine over cosine, so you can see how that is also -1 over negative root 3. I never did the 2's because they always cancel out, which is the same thing as that. So they are equivalent to each other. Okay. Finding an angle using a calculator. This is something that you learned in geometry. If I gave you a right triangle and I said that this length right here is 10 and this length right here is 50, that doesn't make sense at all. Okay, backwards. If that's 10, let's make this 4. And I asked, what is the angle that makes this true? Well, I think 4 is opposite and 10 is adjacent to this angle, so that's tangent. So I would write tangent of theta equals 4 over 10. And then I have to think, I want to undo the operation of tangent. And remember, tangent inverse versus the reciprocal of tangent, cotangent, are different things. You need tan inverse here. So you take tan inverse of both sides. And you have to question, like, do you want your answer in degree or radians? And so we usually put it in degrees for this stuff. So we put degree mode. Let me grab a calculator real quick. So I would go to mode and make sure I'm in degree mode. And then I would type in tan inverse. So that's above tangent. So tan inverse of 4/10. And I could see that that would mean that the angle is 21.801 degrees. Okay? If you were in radian mode, then this would be your answer in radians, 0.381 radians. Okay. Now, that's tangent because I gave you opposite and adjacent. If I had given you, let's say opposite and let's go with this being 4 and let's pretend like this is 6. If I had given you that and I said find theta, well, this is opposite and this is hypotenuse. So then I would say sine of theta equals 4/6 and then theta equals sine inverse of 4/6. So you take the sine inverse of both sides, type it in, and there you go. So like I said, this is very short, so pause the video, write that down, and you can work on it the rest of the period.